Welcome to AP Calculus Lesson 3.5, Day 1, taking the derivative of trig functions. We're going to learn 6 rules, and you have to memorize them in order to pass the AP Calculus exam. The first rule is that the derivative of sine is cosine. The second derivative rule is for trig functions is derivative of cosine is negative sine. And this is kind of interesting to see. If you use your calculator and go to the y1, y2 graphing functions, and you put in the sine of x, you'll see a sine curve. If you use your calculator functions to take a derivative, you'll see that the derivative, and you put that into y2, you'll see that the derivative is the cosine function. So that's kind of neat to look at, and these are described on page 142 of your book. Let's do some examples. We're going to use product rule, quotient rule, rules of derivatives. The first derivative is the derivative of a constant, 3. The derivative of a constant is 0 every day. All right, now we have a multiplier on the sign. So derivative of sine of x is cosine of x, and we just multiply it by its multiplier. And therefore our derivative of this function is for cosine of x. The next function is a function times a function, so we are going to use the product rule. U is x cubed. That means the derivative of u is 3x squared. Our v function is cosine of x, and therefore our derivative is negative sine of x. Don't forget that negative. All right, so now we're going to multiply vu prime times uv prime. 3, and it doesn't matter which way you write these, one plus the other, because addition is commutative. So u prime times v and plus x cubed, although it's going to be minus sine of x. So let's do minus x cubed sine of x. And that's our derivative for example number 2. Example 3 looks like a quotient rule problem to me. So we have a u function over a v function. So let's check out those derivatives. U is sine, and v is 2 minus cosine of x. So the derivative of u is going to be cosine. The derivative of v is going to be 0 minus a negative sign. So that will be plus sine of x. All right, now we need to plug these into the quotient rule. Make sure you use the quotient rule. First we have 2, the v on the bottom, squared, 2 minus cosine x squared, and then we start with the v on the top, 2 minus cosine of x times cosine of x minus sine times sine. That's a sine squared of x. All right, we can do one little thing of simplifying here. If we distribute our cosine to both terms, we get 2 cosine of x minus cosine squared of x minus sine squared of x over 2 minus cosine of x squared. Okay, so I think that we could do something with this cosine and sine. If we took a minus here and made both of these positive, that would equal the same thing as negative cosine squared minus sine squared. And we all know that cosine squared and sine squared equals 1. So now our final answer will be 2 times cosine of x minus 1 over our v squared. And that is our final answer for the third example. Okay, on to the next set of, we're going to do harmonic motion. Yep, forgot about that. All right, so this is an example where we have a weight hanging from a spring and it's stretched 3 units beyond its rest position. And the position function is given by s equals 3 sine of t. What are its velocity and acceleration at time t? Okay, so v is the first derivative of s. So we know that that would be 3 times cosine of t. That's the velocity function. The acceleration is going to be the derivative of the velocity. Derivative of cosine is negative sine of t. So those are our two velocity and acceleration functions. The second part says describe the motion, and the motion's actually described here in the second part. If you look at the velocity function, notice as t gets bigger, the function is going to go down and up and down and up, and it will go from positive 3 to negative 3, and that is actually the motion of the weight bobbing up and down. It goes from negative 3 to positive 3, just like the graph. All right, now there are more trig function derivatives: tangent, cotangent, secant, and cosecant. All right, make sure you know these. We're going to do some examples using these. The first one is find the derivative of 5 plus 2 cosecant of x. All right, well, we know the derivative of 5 is 0. And we know that the derivative of cosecant is negative cosecant cotangent. So we have plus 2 times negative cosecant cotangent. And that's basically our answer. The second example. Oh, this looks like a product rule. A u times a v, because we have a function times a function. So take out your product rule equation and set one of the functions equal to u and the other function v. So we have the derivative of sine is cosine. The derivative of secant of x is equal to secant tangent. And now we're going to use our product rule knowledge and take b times u prime, which is cosine secant. And then we're going to multiply sine times secant tangent. And you might be able to do a little bit more simplifying with this. In fact, I know you can. This is cosine. This is 1 over cosine. So that looks like a 1 to me. Don't forget your trig definitions. This is a sine. This is a 1 over a cosine. And this is a sine over a cosine. So we have 1 plus sine times sine is sine squared, and cosine squared. Wow, this is getting better and better. This looks like 1 plus tangent squared of x. Now, if you look on your trusty purple formula sheets, which you may or might not have right at your fingertips, you're going to see that 1 plus tangent of x isn't on there anymore. I thought I used to have it on there. I'm looking at it. Oh, there it is. It's equal to secant squared. And that is the derivative of example number 2. All right, couple more examples. The derivative of x times cotangent. Again, two functions. Function times a function. Let u be x and u prime be 1. Let v be cotangent and v prime be negative cosecant squared. All right, so again, we're going to use our product rule knowledge and multiply so that the derivative equals 1 times cotangent plus, it's going to be actually a negative, minus x cosecant squared of x. Okay, you got to know your product rules and your quotient rules. Now, before we start the next problem, and I think this is the last one, we are going to rewrite this. Because and be sure that you know how to do this. When you see secant squared, you need to know that it means the quantity secant squared. You need to know that tangent squared is tangent squared. All right, now remember that you can also write these as secant times secant minus tangent times tangent. Now, know that in the next section, I think 3.6, we actually learn what's called the chain rule, which allows us to do this more easily. But for right now, we're just going to use the product rule 2 times on both of these terms, and then we can find the derivative. But there is actually an easier way to do this, so don't get too freaked out. Okay, so the derivative of secant is secant tangent. The derivative here is secant tangent. Okay, so we've got that. Now for our second product rule, we're going to take u as tangent. And u prime is going to be secant squared. And we're going to repeat that for v. Our second v equals tangent and secant squared for the derivative. All right, so let's take our first product rule. Secant times secant. We get the derivative equals secant squared times tangent plus secant squared times tangent. Then we have minus, and don't forget we're going to minus all of this stuff in the product rule. So this is going to be tangent, well, let me write it this way since this one's written. We're going to write secant squared tangent plus secant squared tangent. Get writing fast, I forget a few x's. All right, if you have 2 secant squared tangents minus 2 of those, you end up with the derivative is 0. That's the most fun problem ever. And that is the end of section 3.5, day 1. Thank you for tuning in.